Integral of cosine squared. I already give away the hint how to do it. We don't know how to integrate cosine squared. But we do have trigonometric identities. That's what I just showed you. Formulas, identities. The one it's very useful is the formula number. Oh, let's number them. What number should we use? This was number 1, 2, 3, 4. Which one should we use? First one will be cosine squared gives you 1 minus sine squared, and it's still hard. Number 4. Number 4, we know how to integrate this, and we know how to integrate that. So I think the best one will be to do number 4. Let's try and see how it goes. Number 4 says, bless you, it is 1/2. I kick it outside. It's easier this way. 1/2, and then 1 plus or minus cosine double angle. Plus cosine of 2x dx. Remember, you don't have to put parentheses, actually, because integral starts the integration. Dx tells you where the integration is over. But in some books, you will see the parentheses like so. Now we're using U substitution like it's piece of cake. That's why you need to be on top of your homework all the time to make sure that it is. It's not easy. U substitution is not a simple chapter, but the more you do it, the better you get for this. So you have two integrals, 1/2 integral dx and 1/2 integral cosine 2x dx. Two integrals. The first integral gives you what? Just x, so it's 1/2 x. Plus, and the second one, do you want me to use a shortcut or the whole U substitution? What do you guys think, everyone? Shortcut is better. I will be using mostly shortcuts, and then I will be linking you to the lecture where we explain shortcuts. What should be your U here? 2x. So shortcut says, integrate the way you know. What is integral of cosine? Sine. Copy the angle, 2x in this case. And then what? Divide by the leading coefficient. Exactly. Which is 2. That comes from U substitution. If U is 2x, du is 2, so dx will be 1/2 du. What is missing? Plus c. This is the answer. Or you can multiply 2 times 2. It gives you 4. I don't want to. Questions? What do you think about that? Don't be afraid to ask questions. I always say if you just dropped your pencil and while you was picking it up, you just saw this, it's nice to ask, like, what just happened? So it's okay to ask and repeat something, especially if you zone out for a second. Don't check your phones. It's very hard to go back. So that's a classical approach using double angle formula. The same with sine, if you understand. Now we're getting into something a bit more annoying. There's lots of variations of trigonometric functions. How about, what if it's not squared? Kind of felt a bit cheating. Why it was so perfect squared? What if it's to the 5? Okay, yes, let's figure out what to do with the cosine to the 5. The thing is, it will depend, the strategy will depend if this is odd or even exponent. So first let's check what happens with odd. Cosine to the 11, cosine to the 109, and so on. You only can use this formula number 4 with even, not evil, even exponents. So why not to make even exponent out of odd? Let's see if it works. This is the strategy. You break your cosine to the 5 into cosine to the 4, one lower to make it even, and the rest will be the tail, cosine x dx. You agree, right? It's the same thing. Now, we're not gonna perform double angle formula, actually. What we're gonna be doing is use substitution reversed order. Very interesting idea. This whole week we will be doing some solving of puzzles. All these integrals like little puzzles, and we'll be using different tools and ideas to solve them. What if I'm gonna claim that this is my du, plus or minus? So So if du is in front of me, then from there I know what u should be. If cosine x dx is du, what should be u? Sine. And that's what we're gonna do. But I don't see sine. So how to make sine out of cosine to the 4? Yes?
Cosine squared x whole squared. So that would be 1 minus sine squared x.
Yeah, exactly. People mentioning already several occasions I heard using the formula number 1. Formula number 1 is the classical one. We will need it to calculus 3 differential equations class as well. Sine squared plus cosine squared gives you 1. So we will write it down as cosine square x squared. The tail is waiting to be du. Not yet, but we already know where all this is going. From here, I'm using formula number 1. Sine square plus cosine square is 1. So cosine square or sine square is 1 minus another one. That's how people remember it. It's 1 minus sine squared. So it will be 1 minus sine square x. Everything squared. And the tail will be my du, plus or minus. Like so. Let it sink in. So I used formula number 1, which is sine square plus cosine square equals 1, which means cosine square is 1 minus sine square, which is squared. And there's a tail at the end. This tail will be used to be du. Then u is sine x. This piece is u. Then we'll have 1 minus u squared du. And that's just a polynomial. I will show you how to deal with that. But interesting mindset here. We knew first what du is going to be, plus or minus. And from there we built u. Du is that tail, cosine x dx. That tail, I call it tail. It was waiting to be du. Dx. The integral becomes, can you read me? Anyone wants to read? 1 minus u squared all squared du. And I will stop here and ask you if it's too fast. What do you think? Yes?
When you're doing the u substitution for the sine squared of x, why don't you carry the square sine of x?
Oh, good question. So the question is, why not you choose its square, right? Don't do that. You can choose square, then du will be a bit complicated. It will be 2 sine x cosine x based on the chain rule, and that will not help us to solve the integral. What we want to have a polynomial, 1 minus u squared, because we know how to integrate u squared. So it makes sense to not to choose powers to be in the u choice. Don't choose powers, because we know how to integrate polynomials. So even if it will be at some point sine to the 11/100ths, whatever, choose still sine to be u. Oh, actually the better way to answer your question is because du is exactly this. So to make du cosine x dx, u should be sine x, not square root. Yeah, that's actually a better way to answer it. Good question.
Another question.
Yes?
If you did have a leading coefficient, could you use the whole square function? Because the square function.
You could use then double angle formula if there's nothing additional there. I think that's better. Is that what you're asking? If there's no extra piece, just use double angle formula and it works.
No, if there is the tail has its coefficient on it.
Oh, I see. If there's a tail, but there's no coefficient. Oh, then you will have to deal. Yeah, that's a good question. If the tail is not perfect du, you just have to deal with how derivative will match it. We're going to have this example right now. I see what you mean. What if it's like 5 over here? Or even worse, what if this one is 5 and stuff? We will have that too. Especially with sine and cosine, they can be minus and plus. Derivative of cosine is minus sine. We will have that after this example. Good question. It's not that this is a perfect, nice looking example. Others will be the same, but with hassle of coefficients and negative signs. Yeah. Yes.
So cosine squared x is also equivalent to sine squared.
Yeah, let's write it down again. That was the formula number 1. And then from the formula number 1, I can tell you, actually, let me just write it here, more relatable to the example. Cosine square is 1 minus sine square. And sine square is 1 minus cosine square. So we're going to be using it all the time. Calculus 3, differential equations, all classes in the future. It's somehow really, really magical identity. It's everywhere. Good questions, people. Yes? No? How to solve the integral? Did anyone actually finish it? That's not that obvious, yes? What?
I finished.
Yeah, how did you do it?
So after that, the integral will be 1 minus u squared the whole square du.
Mm-hmm.
And I expanded 1 minus u squared.
How did you, what's the expansion? Tell me.
So it's 1 minus 2u squared plus u to the 4.
U to the 4. Yes, du, exactly. Thank you. So we're using expansion, square of difference. That's my review lecture if you watched it. From calculus, pre-calculus classes or algebra. Square of difference, 1 square of the first one minus double product plus square of the second one. And now integrating piece by piece. Integral of 1 is u, integral of 1 is u minus 2u to the what? Cube over 3, exactly. And then the last one is? 5 over 5 plus c. This is the answer? No. You have to go back and remember what was your choice for u. So most people don't write down this line, whatever I just did. Too long to rewrite it later. Mostly people know, okay, u is sine, so just write down sine right away. It saves lots of time and space. Sine x minus 2/3 sine x, don't forget to put huge parentheses, cubed, plus sine x to the 5 over 5. That is the final answer. As always, you can check it by differentiating this thing. But then it will not give you beautiful results, whatever we had at the very beginning as cosine 5, until you use identities to collapse it back. This is how we integrate cosine or sine to the odd power. So, in general, let me write down. There's a formulas in the book which you can check, and I don't like remembering formulas, so I remember the method. Integral of sine to the odd x dx, or integral of cosine to the odd x dx. You break it into the function to the even times the tail. Let me just do the first one. It will be integral of sine even times, so it's x, sine x dx. That is dx. That is your tail. And this tail will be your du. And u will be sine or cosine. Why it's not? Oh, jumped. So that's like a general idea, and you will be just working with those functions again and again. And then, and use formula number 1. And use formula cosine square x plus sine square x equals to 1. And it works. Then there's a polynomial, and you integrate the polynomial. How about that? How exciting this is, right? Okay, one more. How about the mixture of two of those cases? Sine cube, cosine 5, and so on. Example 3. Example 3. Mixture, getting even more interesting. Yes? Yeah, let me write down. Yes, definitely let me know if it's too fast. And I'm giving you all the notes also, which is good. Sine to the 5 and a cosine square x dx. How about that? So We have one even, one odd. One is odd, that's 5, and one is even, that is squared. The victim will be the odd one. Whatever is odd, you will break into even and the tail. So we're still going to have exactly the same idea. Even and the tail. Same idea here. So find the one who is odd. That is sine to the 5. And we're going to do the same idea here. We're going to rewrite this as sine to the 4x. Let's copy cosine square x and put the extra sign to the tail. X dx. This is my tail. Do you know why I'm doing this? You don't have to reorganize information like this because it's a product. I can put it everywhere I like, but I like to put it at the tail because that's going to be du. If sine x dx is du, what should be u? Cosine, but negative. So it's plus or minus. So this will be minus du. So if sine x dx is minus du, then u should be cosine. So we know this is going to be u. Then it will be u squared du. But what to do with sine to the 4? I would like to convert it to cosine to make it u as well. And we know how to do that. The same thing we just did. So before we perform u substitution, we need to deal with this sine to the even function. We're going to do exactly the same thing. I will make it fast, and you tell me if you understand it or not. 1 minus cosine square x, everything squared. How about that? Do you know what just happened, or it was too fast? And let me rewrite. Cosine square x, and the tail sine x dx. And that is the tail. The purple part, where did it come from? Did you get it, or it's too fast? I skipped the whole step. Sine to, yes? Yes, Formula 1. So let me say it out loud. Sine to the 4 is sine square squared. Sine square is 1 minus cosine square. So now it's 1 minus cosine square squared. So I skipped this step just for you, letting you know. Yes?
What would happen if you made it du to the power of 4?
Du to, you don't make du to powers. Usually doesn't work. You can check. I mean, you have good questions, people. What if we choose sine to the 4u? What if we choose cosine square? Try it and you will see it's not going to work. Unless you use other identities. Some identities make it better. But choosing u or du being with the power usually doesn't work unless you work with secant and tangent, because derivative of tangent and secant squared. So with sine cosine, you don't want to use powers for u substitution. That's the idea. Yes?
So if it was like sine to the 6x, would that 2 change it to 3?
How would we change sine to the 6? Exactly, very good question. I probably should answer at the very end. I will do the note at the very end. Sine to the 6 will be cube square, will be squared cube, right? Square is still 1 minus cosine square, and then it will be cubed here. Very good question. So it works with any even. Let me write it down again. The whole point that it was even, that's why it's working. Okay, if sine x dx is minus du, then what is u? Cosine. And here it is, everywhere. Just choose cosine to be u, cosine to be u, and I'm going to perform u substitution. U is cosine x. Du is minus sine x dx. So that gives us that sine x dx is minus du, exactly what I wanted. So it's interesting, we perform a u substitution, but we know the tail first. We know the du instead of choosing your u. Integral becomes, who wants to read? Sound, people at the back, don't sleep. People at the very back. Who wants to read me the resulting integral? Super fun. Yes? You want? So now we put u in with u.
1 minus u squared
Exactly.
all squared.
Exactly.
U squared
Yes.
sine or the du.
Du. Perfect. Amazing. Amazing work. Thank you. Minus or plus though? Right? So the only thing is we should make a note, maybe here to make it better. Sine x dx end up to be minus du. So this negative sign, let's not make it yellow. This negative sign pops out, and I'll kick it outside, like so. And I'll put it red everywhere. Good job. Thank you. How to differentiate that? So that's just polynomials, which means kind of annoying, lots of annoying work. But let's do it. You first use the same formula we did before, square of difference. So minus integral, square of the first term, minus double product of 1 times u squared, plus square of the second term, which is going to give you u to the 4, times u squared. How would you deal with that? How would you integrate that? What should we do? Distribute. That's a good word. Distribute. Here, here, and here. Okay, u squared minus 2, u to the 4 plus u, 4 plus 2 is 6, not 8. du. Let me stop for a second, I think it's too fast. But we are one step away from the answer. Now we just need to integrate. Who wants to read me the answer in terms of x? So I don't want to answer in terms of u, too much writing, and that's what I recommend you to do. I want to write down everything in terms of x. Who wants to read the answer in terms of x? Yeah, but you already mentioned, you was already talking to anyone else? It's fun. It's like keeping you on your toes, you know? People at the end? People at the end? Okay, you did not say anything yet. Go.
Negative cosine cubed.
Cosine cubed.
X, yep.
Cube x
Divided by 3.
divided by 3. Can you tell me why it's cosine?
Because we get this.
U was cosine x. And I'm going back right away because it saves lots of writing time and space of the paper. Next.
Minus cosine.
Minus or plus?
Oh, I got minus.
So you factored, right? Okay, let's keep it factored. But I would like to distribute negative everywhere. So let's do it plus. Minus times minus is plus. It looks better this way. Keep going. 2.
I have minus cosine 9 over 9, and then plus 2 cosine 5 over 5.
9 over 9.
Oh, I think I have the plus u6 before.
Oh, you add it together. Yeah, we can do that too. We could, no, you cannot. You cannot add u with different powers. So, okay, let's check. 1 times u squared is u squared. Minus 2u squared gives you minus 2u to the 4. U to the 4 times u squared is u to the 6. Right? Agree? So it will be u cubed over 3 minus 2u to the 5 over 5 plus u7 over 7. That kind of answer. And now we're plugging in cosine everywhere. Agree? Yeah, good job. So keep reading. Do you want to keep reading? 2, and then what?
2 cosine 5 over 5.
Cosine 5x over 5. Great. And?
Plus cosine.
Let me do minus, because we're distributing the negative sign.
Negative, minus cosine 7x over
7 to the, 7 over 7. Yeah, amazing. Thank you. Perfect. Plus C. Let's put it in the pretty rainbow box. Yes. It's too fat. Okay. Rainbow box. What do you think about this? Isn't it fun? So the main idea here is, let me write down the idea and then I'm open for questions. The main idea, if you have a mixed situation, integral with sine x and it's raised to the even, and then cosine x and it's raised to the even dx, that's a different situation. Then you use double angle formula, which is number 3 and for formula to decrease the power. That's example number 1. Example 1. See example 1. So if we have all even, you just decrease and integrate using U substitution. If you have even one odd, that's what we do. We're using the tail situation. Unless we have 5 minutes left to do unless part. Bless you. Example 4, I think. What about integral with secant? Secant x to the 4. Secant and tangent behave like sine and cosine, but the only difference is that the derivative of tangent is secant squared. So the tail now, the du part, will be secant squared. Let's do that. So what we're going to do is, we will write down, we want the tail secant squared. The thing is, we know what we want. We want secant squared x dx as my du. So u is tangent. Well, then we're going to have secant x squared at the very beginning, right? So it will be secant squared in this case. Oops, falling. Funny. Equals. If secant squared is du, u should be tangent, but I don't see tangent. So we're going to use the formula number 2, which nobody remembers, to be honest. Well, some people do remember. Secant squared minus tangent squared is 1. Secant is like the cool guy, so I will write down this way. Secant squared, actually like so. Secant squared becomes 1 plus tangent square x. Because the formula is a little bit different. The formula is secant squared x, bless you, minus, right? Let me check just in case, not to mess up. Now, formula number 2, secant squared minus tangent squared equals 1. I always remember that secant is cooler than tangent, because tangent derivative gives you secant squared, and it minus and gives you 1. From there, you solve for whatever you need. Secant squared, tangent squared gives you 1. That is the formula number 2. So we have 1 plus tangent squared, and we have a tail. Secant squared x dx. And we already know this tail will be du. If this tail is du, tangent squared is u. Let's do it. If u is tangent x, du is secant squared x dx. If you don't remember, this is coming from derivatives. So tangent secant squared. Who wants to tell me the integral? Integral will be what? 1 plus u squared du. And we just had this before at the very beginning. So it comes to be the simple one. The answer for 1 plus u squared du is u plus u cubed over 3. Let's write it down again, back to the tangent right away. Tangent plus tangent cube over 3 plus c. This is the best way. I highly recommend to write down the original variable right away, because you're so good at your substitution by now that you just get it. Just get it. Plus c, plus c. Questions about this one? What do you think about that? Don't postpone this homework. It's a bit time consuming. Also, it's a bit more frustrating than others. So you will need more time to just be motivated to do it. That means you should start as early as possible.